So this is a flight into Fukok where everything went correctly. So let's have a look. So currently we're passing flight level 110 and the speed is reducing to 250 knots for the speed restriction at flight level 100. And we're approaching 40 nautical miles. So let's do a profile calculation. So 40 times 3, flight level 120. We're at the moment near 300 knots, but we are slowing down. So by the time we are at 40 miles, we will be at 250 knots. So we'll use that as a reference. So we should fly 2,000 feet lower. So that makes flight level 100 at 40 miles. So at 40 miles, we should be at flight level 100. Now, quick check. We can already see that looks like we will be able to make that. And if we skip ahead a bit until we're exactly 40 miles right there, we can see that, okay, we are slightly above profile. We're about 400 feet above profile, speed is slightly high. So now if this is a problem or not depends on the weight and the wind. So we have a slight headwind and the weight is 63 tons. So that's slightly heavy perhaps. So that's something we should keep monitoring. But for the moment, maybe there's not much we have to we can do about that, or we can do something about it, but we don't have to. Okay, so let's continue the flight. So next altitude check will be at 30 miles. So here approaching 30 miles. So at 30 miles times 3, that's 9,000 feet. We are doing 250 knots. So we should fly 2,000 feet lower. So we should be at 7,000 feet at 30 miles. Okay, now let's see if we can do that. So here is 30 miles exactly, and we are 500 feet high. Again, we check the weight and the wind. So we have a bit more headwind now. So 500 feet high at 30 miles is maybe that's not a problem. So we could use the speed brake to get back on profile, but at the moment it looks like perhaps there's no need for that. So we can just wait and see. You can see that the aircraft is on the VDEF profile. This is not always correct. Sometimes it is, sometimes it's not. It's just a clue. So we definitely have to keep an eye on it. Okay. Now, next what will happen, we start to slow down from 250 knots to green dot speed once we pass 5,000 feet. But before that, you can see that 5,000 feet is actually cleared level here at Tihan, and we cannot descend further unless we pass this waypoint Tihan. So because we are on profile now, or actually slightly above profile, then once we fly level at that point, we have to slow down. Because if you need to descend, but you can't, you need to slow down to force the thrust at idle. Okay, so let's skip ahead a little bit until we approach that point. So here we are approaching 5,000 feet. We are on profile like we calculated before. And here it goes into Alt Star. And as soon as it goes into Alt Star, when you need to descend but you can't, you need to reduce the speed to force the thrust at idle. Okay, so let's see if that happens. Yep, the speed is selected, and it will fly level for a short time here until we pass Tihan. But because the speed buck is lower, and you can see me pointing at the screen here because I'm doing instruction, but because the speed buck is lower, this will force the thrust at idle, and this is exactly what we want. So there's Alt. Now the approach phase is activated, so the speed is managed, so the speed buck will automatically be set at green dot speed. Here we pass Tihan, so now we can descend to the next altitude, which is 4,000 feet in this case. Okay, so the other step for the descent profile is if you need to descend, you can't, you need to slow down, and after you can descend, you need to speed up. Okay, so here we pass our waypoint. Down we go in open descent, and I increase the speed here to make sure the aircraft stays on profile. Okay, so if I backtrack a little bit, we can do an altitude calculation or a profile calculation. So at the moment we are exactly at 20 miles. The speed is near green dot, so 20 times 3 is 6,000 feet, minus 1,000 feet to slow down is 5,000 feet. And we're exactly at 5,000 feet, so we are on profile. So in this case, you could elect to just keep the speed because you're on profile anyway. But anyway, I decided here to increase the speed a little bit. Good. You can see, by the way, we have flap 3 selected for landing due to the weather. It's a bit turbulent. Okay. So next here we are approaching our cleared level again. And the same thing applies as before. If you need to descend but you can't, you need to slow down. So here it goes into Alt Star. As soon as it goes into Alt Star, reduce the speed bug to force the thrust at idle. Okay, and shortly after we can descend further. It's only a short level segment here. Next altitude calculation, or the profile calculation, must be done at 15 miles. Knowing by heart that 15 times 3 is 4,500 feet, but that's without a speed modification. So 4,500 feet, and we're doing green dot, that means we have to fly 1,000 feet lower. That makes 3,500 feet. So at 15 miles, we should be at 3,500 feet. Okay, now just to backtrack a little bit. So because we're on profile, we need to descend, but we can't. Then we slow down, and here at the moment, what will happen soon is the trend arrow will hit the speed target, which is green dot speed, and then the aircraft will add power. And this is not what you want. You want to keep the thrust at idle anytime you're on profile or above profile. So that's why I selected flap 1 here, and the speed is managed. So there's flap 1, and that now S speed becomes the speed target, and that means that the thrust remains at idle because the aircraft can now slow down further. Okay, so now we just passed the last waypoint on the approach with an altitude constraint, and now we can descend further. Personally, I always use vertical speed from about 4,000 feet because that will give me more control over the exact descent rate, and then I can decide exactly where I want to put the aircraft on the approach. Some people use descent mode, but I don't recommend that, because in descent mode you have no control over the vertical speed, and depending where your speed bug is, like if you manage the speed and select flap 2, the speed will go all the way down and you might end up above the glide slope. And some profiles in some airports, depending which aircraft you fly, it's quite steep, and the VDEF will go all the way down, and then the aircraft will shove the nose down trying to catch that VDEF profile while you are not high at all. So that's why I use vertical speed instead. Okay, let's continue. So at 15 miles, normally we select flap 1 anyway. So that's selected here. And so next, what we are looking for is where to intercept the glide slope. So there's 2 different ways to do that. If you are a bit on the low side, then you can continue the descent down to 3,000 feet and then fly level, and then wait until the glide slope moves in, and then when you are 1 knot below the glide slope, select flap 2. The other way, which is happening here, is that if you are more or less on profile, what you will do is you reduce the vertical speed and then fly the aircraft a little bit less steep so that it flies 1 knot below the glide slope. And once it's 1 knot below the glide slope, or just before, then you increase the vertical speed to keep it 1 knot below the glide slope. How much you have to set? Half the ground speed. Okay. So here the ground speed is 186, so let's make it 180, so that'll make about 900 feet a minute. And you can always just modify to keep it at 1 knot below the glide slope. And then when you pass 3,000 feet, and make sure that you are below VFE next, because here you can see it's a bit turbulent. But when you pass 3,000 feet, right there, then you select flap 2 and let the aircraft balloon onto the glide slope. And if the speed is fast, you can also modify the vertical speed to make sure you are below VFE next. So there's flap 2 is selected. The aircraft will balloon. You see that here. It will climb a little bit. It will always balloon about 500 or 600 feet a minute up. It goes into glide slope star. We set the go around altitude. And down we go. So next we want to check when to lower the gear. So if the speed is on the high side, meaning if this is the top of the range and here's the bottom of the range, that if it's from the middle upwards in this range, then you want to lower the gear at 2,500 feet, especially if you have a tailwind. Well, in this case, we have a bit of a large headwind. But if the speed is on the low side, like halfway of the range downward, like in this case, you can lower the gear at 2000 feet. So we are just waiting for 2000 feet and then we're going to lower the gear. So let me skip ahead a little bit. So there we are approaching 2000 feet. You can see the app increasing here due to, this is actually ground speed mini due to the headwind here. So there's 2000 feet, we lower the gear. Now next, when to select flap. If you are very fast, you want to select flap without delay. As soon as you are 5 or 10 knots below VV next, depending on the turbulence, you want to select the next flap stage. But if the speed is on the low side, you can wait until not lower than 1800 feet to select the next flap stage. Okay, we have flap 3 selected, and in our case here, this is the last flap stage for the approach. So next we want to be stable by 1000 feet or 500 feet if you're in IMC. Excuse me, if you are in VMC. But here we are, I believe in this case we were in IMC still, so we have to be stable by 1000 feet. And basically we are already fully configured and stable because we got gear down, flap 3 selected for the approach. And the high speed here, this is just due to ground speed mini, so that doesn't matter. Okay, so that's it. I hope you learned something and thank you for watching. If you like this video, please consider buying my book Practical Descent Energy Management. It contains loads of examples of how to manage a descent and approach, and it is the only book available on this subject. There is a paperback and an ebook version available. You can find a link in the description below.